Hello friends, welcome back, and in this video I will discuss something about the Python libraries in continuation with the hashing. So in the previous video we discussed about the hashing, like how we can use the hash functions to hash a particular value to a particular index in a hash table. So that it is easy to find out the values at a particular index, and the searching of the values will be faster. And now today we are going to discuss about the SHA algorithms, secure hash algorithms. I'm not going to discuss about like how these algorithms work. That will be discussed in the algorithm section, or you can say the algorithm playlist is there. Data structure and algorithm playlist is there. So in that particular playlist, we will discuss about the algorithms. And while discussing the algorithm, when we will reach to the hashing algorithms, we will discuss there that how they work in detail. But today I will just let you know about the basic concept of these algorithms, these SHA algorithms, secure hashing algorithms, and how they are used, how they return the values, how they work. Okay, so let me just open one file, sha.py. So this was already written by me. So to use the hash library provided by the Python, you need to use this hashlib library. You need to import this hashlib library. So you just need to write import hashlib. And if you want to see that how many algorithms has been provided by the Python library for the SHA secure hashing algorithm, then in that case, you can just print this thing, algorithms guaranteed, right? So you can just see like the whatever algorithms are guaranteed to you that they will be working on your system, they are these ones: 1 2 3 4 5 6. These are the 6 algorithms. You can see that SHA1 is there, SHA224 is there, SHA384 is there, SHA256, SHA512, and MD5 is available. So when we talk about the SHA1, then it means that you can hash your value based on the 160-bit values, right? So when you are hashing through this SHA1 algorithm, then it means that you are hashing your value for those values which can be represented using the 160 bits, various combinations of 160 bits, right? Suppose you have 5 bits, then how many combinations you can have? 2 raised to the power 5. Similarly, if you have 160 bits, then how many combinations of the values which will be hashed, how many hash values can be generated? 2 raised to the power 160, right? And same is true for this SHA224, SHA384, SHA256, and SHA512 and MD5. In case of MD5, some extra padding is done apart from the number of bits available. In case of MD5, you have only 120 bit 8 bits available, but in case we are using the MD5, then in that case extra bits are added. Extra bits are added, which is known as the bit padding, and they are added in such a manner that they are less than the number of bytes are less than the 512 number of bits from the total bits. They should be in the 512 bits multiple, right? Suppose if you have 1000 bits, and if you are using the MD5 algorithm, then you need to divide 512 by 1000. So if you do the calculation, 500 and it's 1000 divided by 512. So whatever remainder will be there, I cannot print the remainder here. Like, let me just print the remainder. 1000 divided by, or you can say the remainder, I need to find out. Then how to find it out? Okay, just let me tell you, 512, and this will go once, so you can just minus it, minus 512, so 488 bytes. So you need to pad, how many bytes you need to pad? If you have 1000 bits, then you need to pad how many bytes? Because 512 into 2 is 1024, right? So 1024 is the number of bytes needed to have to be in the multiple of 512, but you have 1000 bits. right? So what you will do, you will add 24 bits extra, right? So this is the way they are calculated, but in deep we will discuss when we will discuss all these items in the algorithm section. All right, so this is the set of those algorithms that you can use, right? And you can check that how many values, what is the value that you are able to generate. One example you can take from the SHA 256 is that where it is used. It is used when you are doing some online transaction. There it is used. Even in case of your credit card algorithms, where your credit card matching is done, that place it is done. So you need to understand one thing, that these SHA algorithms, or you can say the secure hashing algorithm, these hashing algorithms are not equal to the encryption. These are not encryptions. You cannot decrypt any value after encrypting, after getting any value, right? Even if you provide the content of entire book, then also whatever value will be represented through these algorithms, that will be of the fixed length. All these values produce the fixed length. All these algorithms produce the fixed length results, fixed length hash value, right? So they will be of always fixed length, no matter how big your data is. And if you want that, if you want to get the data back, what was the original data, if you want to decrypt it, then I'm sorry to say that it cannot be done, because it's not encryption or decryption. It's hashing. It's just a calculation for validation of the values which you use during the during the password validation or all those things, and your credit card validation, all those things. So those are the places where these things are used, these algorithms are used, but you cannot use them as a decryption encryption tool, right? So this thing you need to take care, and this thing you need to keep in your mind, right? So if you want to see all the algorithms that are available that you can use, but they are not guaranteed, they are all not guaranteed to run, they can be printed through this hashlib dot algorithm available. So these are the number of algorithms which are available. If you want to use any one of them, you can use any one of them, but how many of them will work, how many of them are guaranteed, that will be printed through this algorithms guaranteed, right? So these are the two functions using which you can see that what are the algorithms that your system can support, right? So now we are going to use various algorithms, and let's see that what are the various values generated through those hash functions. So if I use hash sha hashlib.sha 1, and if I produce something like my name, and if I want to see like what has been printed there, k.decode, then let me just see what happens. Oh, okay, this k has nothing like decode. You can only decode encode the values. So you can just see this is the value, this is the address of the value. If you want to see that how these things can be printed, then let's see Vikash Shakya, and then just do like l dot encode, and then let's print the value, right? So this will be the value that has been printed here. So this is the object which has been printed here, but if we have to print the value, then what we need to do, okay, you can print the hex digit, hex digest, these things you can print, right? So if you want to print it in hexabit decimal numbers, then what you can do, k dot hex digest, and let's see what has been printed now. So this is the hexadecimal value of the hash value that we have calculated right now. Okay, so this is the way you can see the results for the hash values that has been generated using these secured hash algorithms. So if you want to see what 256 SHA 256 returns, then in that case you can see like this is the value that has been returned. Okay, so doesn't matter how big your value is, the length that you have seen, that will be always same. So if you write like something like this, no matter how big is your key, if you just run it, then you will be able to see that it's always of fixed length. But based on the values that values you have passed, based on that, it will generate the different hex values, but the length will always be same. Okay, similarly you can have MD5. So you cannot know like how these are calculating these things, how these values are getting calculated, but you can understand that how these are getting done. So in case of MD5, I told you like extra padding is done. How that is done, I have already given you a small idea. That is not complete and that is not full. So for full algorithm, you must have to visit someday the algorithms playlist. And I will try that in case of algorithms, in algorithms playlist, I should put something related to the secure hashing algorithms only first before any other topic. Okay, so these are the algorithms that you can use, and mostly these algorithms like hash libraries, these are used in case you are going to create some application which is working based on the blockchain technology. So blockchain technology, you might be aware, like if you have understood something about the blockchain technology, then you must be aware like these blockchain technologies and blockchain algorithms uses the hashing. They use the hashing. All right, so different hashing algorithms are used, like sometimes they use MD5, sometimes they use 384, like there is one more SHA 384. So if you use this one 384, then in that case result will be something else, right? So this is the bigger key. So as many bytes you will use, you will get as many numbers in the length of the string. And that is why in case of blockchain technologies, they use the bigger secure hash algorithm functions like SHA 384 or MD5. They are used. SHA 256 is considered to be secure and most useful, so that is mostly used, right? So in case of your cryptocurrencies, where your blockchain technology is used, there as well it is used. And anywhere, if someone has changed the value of someone has done some tampering with the transactions in the blockchain, then in that case what will happen, the hash value will be changed and everyone will be aware that yes, something wrong has been done, someone has tampered with it. And that way blockchain technology maintains the integrity and transparency around the globe, or to all the stakeholders. You can say that with all the stakeholders which are using, which are the stakeholders for that particular transaction. Okay, so that's it for today, and I just have to give a small idea about all these things. In the next video, we will discuss about some other libraries related to the Python. And till then, have a nice day. Bye bye. Please like, subscribe, and share my videos, and like, subscribe my channel. We will meet soon again in the next video. Till then, have a nice day and bye bye.